Hi, I'm Arunima Ray, although I usually go by Aru. I grew up in Calcutta in India, but then I went to the US for my undergraduate studies. I was in the US for my undergraduate degree and also my PhD. I got my PhD from Rice University working with Tim Cochrane. Afterwards, I did a postdoc at Brandeis University for a few years. And then I moved to Germany. I've now been in Germany for the past 7 years. My current position here at the MPIM is Lisa Meitner Research Group Leader. And then next year, I'm moving to the University of Melbourne. I work in a field of mathematics called low-dimensional topology. Low dimensions to me means 3 or 4 usually, although there are people who study two-dimensional manifolds as well. Part of what I like about low-dimensional topology is that it's very concrete. You can draw very explicit concrete pictures, and your geometric intuition is something that's really useful in this area. This is an interesting question, so I thought a lot about this, and I thought I would tell you the following story. It's about how I proved my very first theorem. So this was when I was a PhD student, which was back in the US. And as a PhD student, I don't know, I was very lucky to be in a very supportive department, but it was also, I chose very late in life to go into mathematics, so I don't know, I struggled a lot with confidence, and especially in my first year that I was doing research, it was something that I was really struggling with, the whole process of it. But my advisor had given me a problem, and we would talk about it every week, and I just felt a lot of pressure, and so there was just, I didn't really know how to go about it. But then one day I was in a meeting with my advisor, and I was just telling him, here's the thing that's obviously true. And it was just something that I'd never really thought about at all. I was just like, oh, this thing is obviously true. And he just looked at me and said, well, that's the proof of the theorem. It's like, no, that can't possibly be true. And it's like, no, there it is. Think about it. And then like 2 minutes later, I was like, wait, I really did prove it. And it's just, I feel like because I was under so much internal pressure, I kind of had to trick myself into proving something. So I couldn't do it consciously. So it kind of happened just by accident, and I didn't really even notice until my advisor pointed it out to me. And that was the first time I'd ever proven anything. And the nth time is easier because you know that you've done it before. But at least for the first time, I had to sort of sneak up on the results, and I don't know, I thought that was very interesting. I also thought this was a good question. I have a realistic answer for you, and maybe a more interesting answer. So realistically, I said a moment ago that I decided to go into mathematics relatively late in life. Earlier in life, I was a biochemistry major as an undergraduate, and I had wanted to become a medical doctor eventually. So I think, had I not seen mathematics, had I not met the mathematics professors who inspired me to go into mathematics, there's a decent chance that I would be a medical doctor right now. A more interesting answer, though, in terms of like what I would really want to do, is I would really like to be a stand-up comedian. I think, especially in mathematics, we do a lot of, we give a lot of talks. It's not something that we're necessarily trained in, but it's a very important part of our job. And I think the skills that go into giving a good talk, keeping your audience engaged, actually conveying information, I mean, that's the sort of thing that I would like to understand more and better. And I just have a lot of respect for comedians who can sort of do this in a professional setting and make people laugh. So that's what I would dream of being in an alternate life, or more likely that I would be a medical doctor. So outside of mathematics, I like a number of things, although recently I haven't had as much time to devote to them as I would like. Probably the thing that I most enjoy doing are puzzles. So here at the MPIM, we also have a weekly board game gathering where we all come together and play board games together. But even my favorite board game is something that's really puzzle-based. It's a game called Ricochet Robots, which is very much about you're given a visual puzzle and you have to solve it. But I like puzzles of all sorts. I like Sudokus, I like jigsaw puzzles. if I had an infinite amount of time, I would probably sit down with an infinite number of puzzles. That's a good question. I think perhaps let me answer it in the sense of what I wish I had known before I started in mathematics. Certainly when I was growing up, I didn't know that a career in mathematics was even a thing. So for me, I was already an undergraduate when I met my mathematics professors, and I even understood that it was possible to be a professional mathematician. And I feel like that sort of awareness would have been a really great thing to have before. But even when I knew that that was a career option, I had not realized that mathematics can be very collaborative. So some of my best friends are my collaborators, and working with them on papers is essentially like hanging out with your friends, talking and working on things that you're all interested in. So that's really amazing. So mathematics is not a solitary activity. So I think knowing that is something that would have been very useful to me as a younger person. And in terms of actual advice, I think what I would like to share primarily is that there's no one way to be a mathematician. You might have in your mind a vision of what a mathematician is like, or what a mathematics career is like or should be like, but there are no rules about this sort of thing. So there are all sorts of people that do mathematics, and if your way of doing mathematics is not, the canonical traditional way of doing mathematics, that doesn't mean it's not correct way of doing mathematics. And it's also so important to have confidence. I said a moment ago that when I was trying to prove my first theorem, I didn't have any confidence. I had to sort of sneak up on it. And it's really hard. How can you possibly have the confidence to know that you're going to do something that no one has ever done before? I can't say that I know now how to do these things, but it's happened enough times that I have some amount of confidence that it will happen again. But that's really the most important thing, is to have confidence in your own abilities, keep working hard. You might not end up proving the result that you started off wanting to prove, but something interesting will probably happen along the way. And that's the whole process of research in the first place. If you already knew where you were going, then it wouldn't be research. The atmosphere at MPIM Bonn is all about the people who are at any given moment at MPIM Bonn. So we have very few permanent researchers here. We have an excellent administrative staff who kind of make the lives of the researchers as easy as possible. So essentially, while you're here, you have complete freedom and flexibility to focus on your research. Because we have such a constant flow of new guests and new visitors, the atmosphere can really change depending on who's there. But what doesn't change is that there's a lot of people here who are all interested in doing mathematics. So no matter who is there, you will always find people at tea talking about mathematics, not necessarily just people who are in the same area, but also people from a lot of different areas. So I think, so if I had to condense the atmosphere of MPIM into a few words, I would definitely focus on the freedom and the flexibility. The administration really tries to make your life as simple as possible, so you can spend as much time as you like on your research. I think this sort of freedom and flexibility is something that's important not just to people who are here as postdoctoral scholars, because it really gives you a chance to develop your research program. But it's also very important for people who are here on sabbaticals, because then you have a lot of things that you're working on, but now you have the time and lack of distractions, so you can really focus on your projects and finish them. And the other thing I wanted to mention is that it's true that people can come here to get away from everything and work on your own project in your own office. But the other main thing that really happens here is collaboration. Because you're here there's really no other place that I have ever been at which has this property where you're just surrounded by 100 different mathematicians. working on really hard problems. And so this is the perfect place where you can make unexpected connections between different areas, between different people. So, freedom, flexibility, unexpected connections, collaborations, very easy. Everything outside of research is just made very simple for you.